In this video, we're going to talk about finding the magnitude of a vector, and we're going to start off with a vector in 2D space. So our vector v here has a vx component of 2 and a vy component of 4. In two-dimensional space, if we want to figure out what the magnitude of this line is, or the length of this line, all we really have to do is create a right triangle, label the sides, and then use the Pythagorean theorem to figure out what the hypotenuse of that triangle is. The formula for finding the vector of magnitude is also written like this. Vector of the magnitude is equal to the square root of vx squared plus vy squared, and that comes directly from the Pythagorean theorem. So if we just plug in our values now, we get that 2 squared plus 4 squared equals the magnitude of v. This is going to be square root of 4 plus 16, square root of 20. And we can simplify this a bit to the square root of 4 times the square root of 5, which is 2 times the square root of 5. And so using simple trigonometry in the Pythagorean theorem, we can figure out what the magnitude of a two-dimensional vector is. For this example, we have a vector with vx equal to -3 and vy equals to 3. So to find the magnitude of the vector, we're again going to create a right triangle like this, label our sides, and then figure out what the hypotenuse is. So when we're dealing with magnitudes, we're never really going to have a negative magnitude, since magnitudes by definition are always some positive value. So when we solve this using the Pythagorean theorem, what we're going to see is that we end up just squaring away the negatives. So we have -3 squared plus 3 squared, so x squared is going to equal 9 plus 9, and then x is going to equal the square root of 18. So for 2 dimensions, finding out what the magnitude of a vector is really just a matter of creating a right triangle and then finding the hypotenuse. In the next part, we're going to look at some 3-dimensional examples and see that it's really not too much different from this. To find the magnitude of a 3-dimensional vector, we're going to follow a very similar process. We can write it out so it looks like this. The magnitude of vector v is equal to the square root of vx squared plus vy squared plus vz squared. And so here we have vx, vy, and vz. And so all we're going to do is just plug them into this formula over here. We're going to have the square root of 2 squared plus 4 squared plus 6 squared. And so when we do this, we get square root of 56, and we can simplify this down to the square root of 4 times square root of 14. 14. And then this is going to be 2 square root of 14, and this is equal to the magnitude of our vector. So all we're doing is taking each component, squaring it, and then we're adding them all up and finding the square root. We'll look at one more 3-dimensional example here. So now we have a vector v with vx equal to -3, vy is 4, and vz is -2. So let's write out our formula for the magnitude, which is going to be the square root of vx squared plus vy squared plus vz squared. And then we'll plug in what we have. So here we're going to have -3 squared plus 4 squared plus -2 squared. This is going to give us the square root of 9 plus 16 plus 4, square root of 29. Final answer.